Hey guys, welcome back to the channel. Today we're working on a little project where we're going to integrate some battery technology into this AC fan. Since it's AC, that means we're going to need an inverter, and we're going to need a bunch of other parts that I'm going to go over here to make this work. So let's go over our bill of materials, or BOM. This is going to need a pretty big base to sit on, and my 3D printer would not handle a base that size. So what I did is came up with this little modular system. Just printed some walls. We have holes for screws that will connect to a base and a top. And so this is three sections that make up the back wall, and they use a circular pattern die here to fit into a piece like that. So that's a curved section. And then I've got a piece for a vent because the inverter is going to be in there. It needs air to get through. So we've got four corners, we've got some walls, and then to hold the electronics that face the outside, I came up with this little system here that uses a little L in the print to hold what I call inserts. And the inserts I've got one for holding a USB, so this will have USB on it. This is just 12 volt. We've got an insert for charging, so we have banana connectors so we can handle a higher current charge, and then we have a little barrel connector that can handle just a plug-in. So if we don't need to charge fast, I have a power brick that we can use for that. And then I've created one for the power meter, so this will give us a percentage of battery left, how much current's being drawn. And so that's an insert, and then I have an insert for the inverter fan that will be used to keep the inverter cool when it gets warmed up. This will be the inverter we're using. It's a 300 watt pure sine. I've already taken it apart, figured out all the electronics I need to do and such. We have these, which are my battery compartment holders. I designed them in two pieces so that I could print this one in this direction, and then I could print this one in this direction without having to do overhangs, and then super glue them together to create one battery box. So the way these work, I have these nice 25 amp hour LifePo batteries. They fit in the socket here, and then they will latch into place. It's hard to do with this one-handed. Either way, they get in there, latches, so we'll super glue these to the base, and we'll see how that all looks when it's wired up. Got a 40 amp BMS that should supply more than 300 watts that this inverter will use. We've got our power brick, and so the next step is I've already CNC'd this base with all the holes needed for all the walls. So I'm going to put it together, and the two things we need to check is to make sure the distance between our pieces here match this sample prototype, and make sure that the insert fits loosely or hopefully with a little bit of friction so they don't kind of shuffle around. So I'm going to work on that now, and then we're going to lay out the components inside and then see where we want to put the screws for the fan on the top. And we also have these power buttons that we're going to need to place on top. One is for USB, turn that on and off, and the other one will be for the inverter. And so one cool thing about the way this is working is that since this fan is designed to have kind of like an extension cord function, is that when I run this to the base, it's going to have those two available. So I'll be able to use this just as a fan, or if it's off, I can still use the AC. Even when it's on, I'll still have about 150 to 180 watts available to me on that connection. So let me put this together and see how we're going to lay things out. All right, be right back. All right, we got some stuff assembled, and we've learned a few things. My math was off on these gates. I don't know how I did that so badly, but all of them need to be adjusted, so I'm going to have to reprint some parts. But I got the proof of concept. These walls are nice and sturdy. I have no doubt that when we put the top on and screw all those in as well, that it'll be able to support the way the batteries, electronics, and the fan can be carried by its handle, and all of that should be fine. So let's go over the layout real quick. I didn't even print these these walls here. I'm going to print those, but I need to adjust these, shorten them up, and shorten these up to make room for the gates. But like I said, if you notice on the gates, we have those little latching systems, and they just fall into place, or when they're right size they will. But here's the layout. We've got the inverter torn apart. So on this gate, we're going to have the fan, and right near it, we're going to have the USB connections. And then on this side, we're going to have the input of the power right next to the battery meter, so we can run those cables very shortly. As you can see, the batteries fit very well. There's lots of space, still room for the BMS. And for our power switches, I was going to mount them in the wood, but since the fan is going to sit like this, there's not going to be a real easy way to get to the switches on the wood because it fills it up pretty much. So I'm just going to install them right here. This pillar can be unscrewed from the base, so I'm going to mount them in there and then run holes down and let the wiring get to where I need to get it. So the next step is I got to redesign and 3D print some of these parts. So when we come back, we'll have the whole thing connected with the right gapping for the gates here, or inserts, and then we're going to go from there. All right, see you in a little bit. All right, got the updated pieces being 3D printed now. That's going to take a little while. When I decided to do the buttons on the fan part that comes off the top there, luckily this thing comes apart really nicely. Two pieces. I was able to find the center of those two holes, and that's two sections, and that's where I put my holes. I was going to use my little nice 3D printed button enclosure, but it wasn't going to fit. I needed this post to be as high as possible to give clearance for all the terminals underneath, so I decided to make it exposed. I have not decided yet how I want to label it, because one will be for the inverter, one will be USB. I'm thinking about 3D printing a little tag that can just be put over that and then screwed in, or use another bolt to hold down. Or I might try to see what laser engraving. I have a Snapmaker 2.0 that has a laser module, so I might see what that looks like. But I'm leaning towards maybe just 3D printing a little cover with a USB and an inverter, or a little lightning bolt or something. But either way, I love these switches. They're nice and clicky. Not that I need it, but they have multiples. So once one switch is up, one pair is energized or connected, and when you slip it, the other two. So you could actually run up to 3 different devices per switch, but I'm only running the one. But I do have another project down the line where I will need that, and that's why I bought these particular switches. So that part's done, and we're waiting on the rest of the print, and then we'll finalize our design. Alright guys, now that we've got all the wall assembled, inserts in place, I've finalized where I want all my components. On this insert we have the fan that will feed the inverter. This is the one we kind of took apart. It has a little connector there for the fan, and then there's a switch here that we will salvage from the casing. Here we have the 2 USBs that will also be on a switch. And then we'll have our power feed, which has, again, the banana plugs, and then also a barrel connector. And then on this side, we have our battery meter, and then here's the shunt. BMS looks like it could just kind of go right here. Got plenty of space to work with. Eventually, these wires will be tied in directly with the fan. I've decided that the fan orientation, the front of the fan will come out this side. So this is what you would see. And so that will put the switches right around here. So one will control the USB, one will control the inverter, so you can use one without the other. And then the power for the fan will come down through this corner, and then we'll connect to these wires here, and everything will be nice and neat. So when we get back, you'll see all that wired up, and we'll finalize, put the top on, and paint it, and it will all be a done project. So let's look forward to that. See you in a little while. Alright guys, I've got a lot of work done here. Let's catch up. We've got the inverter mounted here, and this fan insert right here that gets connected back. This switch will run over to another switch that we'll talk about here in a second, and I haven't hooked up this part yet. That's what will connect to the fan directly. We created here a couple of bus bars, one for positive, one for negative. You'll see leads going over to the power insert. So we got, the banana plug for ground, positive, and then they have cables that come over to the barrel connector. And then over here we have the power meter that's been connected. Right now the BMS is turned off, and this is the shunt. We've got all our batteries glued into place, and we've got copper tabs that we've created. We've got all our wiring, our leads, the thermal. Really much not, I know that's only reading one battery, but if there's a problem, hopefully it catches it. But I'm not ever going to run this super hard, so I don't think heat's going to be too much of a problem. I have went ahead and run the fan in this configuration just to make sure that this doesn't get too hot and that the fan kicks on, and it does. And I think with the vent here that we have, we'll have all that. We also have the LED for the inverter, which is just a red and green, just lets you know that it's, it doesn't have a beeper on it, so when it gets low it'll just start cycling on and off until it totally dies. But that light will let me know that that it's finding a fault and is not functioning correctly, or not enough power in the voltage. BMS is just a little loose right now. I think they're just going to hot glue it down. It's pretty non-motional, so that's it. We've got the top CNC'd. These are the pillars that are at the bottom of the fan. We've got switches installed. One will be for USB. The other will be for turning on the inverter or the fan. And so those are just on-off switches with I got 2 sets of wires running through, and those will go. One will power, like I said, the USB module here. Just for length, I have the positive wire on the bus, and then so the wires will go from here in the bus bar. And the other one, I will cut off this switch and attach these wires. And this has a nice little plug on the circuit board down there, so I don't want to. I want to use that. So that's it. So the next thing we're going to do is put it all together. I may or may not paint it. I probably won't. And I got to put a hole here in this corner to run the power through here, and then connect up to the inverter wires there, and then we'll call it a project. So let's work on that now. Alright guys, we're finished. We've got everything assembled, and so I just wanted to go over it one more time. We've got our AC fan, has multiple speed control. It has 2 AC outputs that we can actually use directly wired into the inverter. We have USB for charging cell phones or whatnot. We've got our power port, we've got the banana connectors, and then we have a barrel connector. The great thing about these banana connectors is we can actually add capacity from other battery packs we've built, and make it last a bit longer. Just a warning: whenever you do parallel adding a battery pack, make sure the voltages are very close, or else a lot of current is going to run through. In a best case scenario of a failure, the BMSs will just kick in and not just turn off, or if the amperage is high but not enough to kick off the threshold of the BMS, you could melt the wires you're using. So be careful. In the front, we have our battery meter. It's not lit because nothing's being drawn right now. We can fix that. We have 2 buttons up here. This one connects to USB. So now that USB light is on. And then this one connects, turns on the inverter. The fan is started. And now we are drawing amperage. And so there you go. We've got ourselves a completed project, and I hope you liked it. And if you feel like leaving any comments, I'd love to read them. And if you'd like to do a project like this yourself, I'd love to see what you do. All right, guys.